Hi dear students, this particular class I want to discuss about random variables and probability distribution. What is a random variable? A variable whose values are numbers. A variable whose values are numbers determined by the outcomes of a random experiment is called a random variable. Suppose you see here a random experiment of tossing a coin twice. When a coin is tossed twice, you know what are the possibilities. You may get two heads, you may get head, tail, you may get tail, head, or both the tails. These are the possibilities when a coin is tossed twice. X denotes number of heads. X denotes number of heads when a coin is tossed twice. When a coin is tossed two times. Now tell me, what are the values taken by X? X denotes number of heads when a coin is tossed two times. So X takes the values because the number of heads 1, in this case 0 heads. In these two cases only one head. In this case we have two heads. That's why number of heads 2 possible, 1 also possible, no head. So now the respective probabilities I am finding. P of X is equals to 0. When X is taking the value 0, what is the probability? When X is taking the value 0, what is the probability? So P of X is equal to 0 is 1 by 4. P of X is equals to 1. When X is taking the value 1, what is the probability? That is 2 by 4. When X is taking the value 2, the probability is 1 by 4. Right? So the random variable X takes the values 0, 1, 2 and their respective probabilities are, in case of 0 the probability is 1 by 4, in case of 1 the probability is 2 by 4, in case of 2 the probability is 1 by 4. The random variable X and their respective probabilities are represented in a tabular form. This is called probability distribution of a random variable X. So X denotes the number of heads when a coin is tossed twice. So X takes the values 2, 1, 0. The random variable is taking the values 2, 1, 0. Each case the probability we are finding. Now random variable X and their respective probabilities are represented in a tabular form. This is called the probability distribution of the random variable X. You can observe in every probability distribution table, whatever probabilities we are getting, sum of all these probabilities we have to get 1. At the same time, 1 by 4 into 0 plus 2 by 4 into 1 plus 1 by 4 into 2. So this is called expectation of X. That is nothing but mean of the random variable X. At the same time, the second one here is 1 by 4 into 0 square plus 2 by 4 into 1 square plus 1 by 4 into 2 square minus mean whole square, which is called the variance of X. Variance of X is denoted with sigma square. The square root of variance is called standard deviation. So these are the ideas we are going to discuss in the random variable and the probability distributions. So what we are saying, X is the random variable, that X takes the values x1, x2, x3 and so on, xi and so on, xn. These are the values taken by the random variable X and their respective probabilities are nothing but P1, P2, P3 and so on, Pi and so on, Pn are the respective probabilities. then the first point is summation I is equals to 1 to n pi. Sum of the probabilities we have to get always 1. And the next point is expectation of x, that is nothing but mean of the random variable, is given by summation I is equals to 1 to n pi into xi, that is mean of the random variable. And the next one we are discussing about variance of a random variable x. Variance is equals to summation I is equals to 1 to n pi into xi square minus mean whole square. So this is the variance of the random variable x, and the last point which we are calling this one as sigma square. Next, square root of the variance is called standard deviation, that is denoted with sigma. Now sometimes they will ask the problems and they will give the questions like this. So x and their respective probabilities are given in this way. X takes the values 0, 1, 2. Their respective probability here it is given 0.7, 0.2, 0.1. Whether it is a possible probability distribution or not, we have to say. Yes, the first one which I given here, it is a possible probability distribution. The reason is you can observe sum of the probabilities we are getting 1. So it is a possible probability distribution. Here they have given 0.8. Next here they have given 0.3 and here minus 0.1 given. Whether it is a possible probability distribution or not. No, it is not a possible probability distribution. The reason is probability, yes, this sum we are getting 1, but probability never be negative. So it is not a possible probability distribution. The other case, x is taking the value minus 1, 0, 1, 2 and their respective probabilities are given as P of x is equal to 0.3. Here we are getting 0.4 and this is 0.1 and this value is 0.05. This is a possible probability distribution or not? No, we are not getting sum as 1. This total sum is not equals to 1. That's why that is also not a possible probability distribution. So whether the given probability distribution is a possible probability distribution or not, that is the first model. At the same time, so this is the another question given. A random variable x represents number of heads. Difference between number of heads and number of tails when a coin is tossed 6 times, right? X represents the difference between number of heads and number of tails when a coin is tossed 6 times. When a coin is tossed 6 times, these are the possibilities. You may get 6 times head, you may get 5 times head, you may get 4 times head, you may get 3 times head, you may get 2 times head, you may get only 1 time head, or you may not get a head. These are the possibilities when a coin is tossed 6 times. No doubt. Again in this case only 1, but here we have 6 factorial divided by 5 factorial into 1 factorial. That's why total 6 possibilities are there, because they can be arranged in these many ways. That means tail may occur in the last chance, tail may occur in the 5th chance, tail may occur in the 4th chance, tail may occur in the 1st chance also. Next, here also we have 6 factorial divided by 4 factorial into 2 factorial. So like that we are getting 6 C2, that is nothing but 15. So like the different possibilities are there. Those are all not required at this stage. Okay, observe here, x represents the number of heads and number of tails. Difference between number of heads and number of tails when a coin is tossed 6 times. Now he is asking what are the values of the random variable x. So now tell me in the first case, difference between number of heads and number of tails is equal to 6. Whereas in the second case, difference between number of heads and number of tails is equal to 4. 5 heads and 1 tail, difference is equal to 4. Next case, the difference is equal to 4 heads and 2 tails, difference is equals to 2. Next case, the difference between number of heads and number of tails is equal to 3 heads and 3 tails, difference is equal to 0. Next case, number of heads and number of tails, number of heads is equals to 2, number of tails is equals to 4, difference is equals to -2. Don't say, difference is always bigger number minus a smaller number. Difference is always, we have to say positive only. That's why in this case also, difference between number of heads and number of tails is equals to 2. Here also, difference between number of heads and number of tails is equals to 4. Here also, the difference between number of heads and number of tails is equal to 6. So that's why x takes the values 0, 2, 4, 6. Right? So this is another question he is asking to find the probability distribution. Whenever he is asking probability distribution means you have to think about the tabular form. Find the probability distribution of number of heads. Number of heads when a coin is tossed 3 times. Find the probability distribution of number of heads when a coin is tossed 3 times. Now when a coin is tossed 3 times means you know the possibilities. H 3 times. This is the next possibility. H, T, H, H, T, T. Next T, H, H, T, H, T, 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 H and T, T, T. So these are the possibilities when a coin is tossed 3 times. Now X denotes the number of heads. Number of heads is equal to 3. Here number of heads is equals to 2. Here number of heads is equals to 1. Here number of heads is equals to 0. That's why the random variable x takes the values 3, 2, 1, 0. X takes the values 3, 2, 1, 0. And their respective probabilities also we have to write. P of x is equals to 0. What is the meaning for that? X is taking the value 0. Number of heads is equal to 0. What is the probability? Number of heads is equal to 0. The probability is equals to 1 by 8. Next, P of x is equals to 1. X is taking the value 1. Yes, x is taking the value 1 in this case. Here also x is taking the value 1. Here also x is taking the value 1. That is equals to 3 by 8. Next, x is taking the value 2. What is the probability? X is equals to 2. This is the case, number of heads is equals to 2. This is also the case, number of heads is equals to 2. Here also number of heads is equals to 2. That's why we are getting 3 by 8. Next one is P of x is equal to 3. X is taking the value 3. The probability. This is the case, we are getting x is equal, number of heads is equal to 3. So that's why 1 by 8. So the random variable x and their respective probabilities also written. Now we have to show it in a tabular form. X takes the values 0, 1, 2, 3 and their respective probabilities are given by 0 case we got the probability 1 by 8. 1 case we got the probability 3 by 8. 2 case we got the probability 3 by 8. 3 case we got the probability as 1 by 8. So this is called the probability distribution of the random variable x. Whenever he is asking probability distribution, so this entire information we have to show. Now observe here, probability distribution of number of heads when a coin is tossed 3 times. There ends the matter. Suppose in the same problem he is asking, find the mean of the random variable x. He is asking for finding the mean. Then what to do? Mean is nothing but expectation of x. That is given by 1 by 8 into 0 plus 3 by 8 into 1 plus 3 by 8 into 2 square plus 1 by 8 into 3. So this is the mean of the random variable x. 1 by 8 into 0, 1 by 3 by 8 into 1, 3 by 8 into 2, 1 by 8 into 3. Sigma pi into xi denotes the mean of the random variable. Now you can say this particular value is equal to 0 plus 3 plus 6 plus 3 divided by 8, that is equals to 12 divided by 8. We will get the answer as 3 by 2. Suppose he is asking in the same problem for finding the variance of x. But how to find out the variance? 1 by 8 into 0 square plus 3 by 8 into 1 square plus 3 by 8 into 2 square plus 1 by 8 into 3 square minus mean whole square. So this is given by the variance. You can do this simplification for finding the variance of the random variable. So another question, he is asking to find the value of k. The question is given in this way: x takes the values 0, 1, 2, 3, 4, 5, 6, 7. These are the values taken by x, and their respective probabilities also given like this. P of x is equal to 0, k, next they have given 2k, 2k, and next they have given 3k, next k square, 2k square, k square, 2k square, and the last one they have given 7k square plus k. So this is the probability distribution given. Then he is asking to find the value of k. How to find out the value of k? K value we can find out easily by our known information. What is the known information? Sum of the probabilities we have to get 1. That's why 7k square plus k plus 2k square plus k square plus 3k plus 2k plus 2k again plus k plus 0 is equals to 1. Sum of the probabilities is equals to 1. Now we are getting this one as a 10k square, 4k, 6k, 8k, 9k minus 1 is equals to 0. Now I can write this one as a 10k square plus a 10k minus k minus 1 is equals to 0. If you take 10k common, you will get k plus 1 minus 1 into k plus 1 is equals to 0. Therefore, we are getting k value is equals to 1 by 10. K value is equal to minus 1. K value never be negative, because if k is equal to negative, we are getting probability negative. That's why k is equal to minus 1 not possible. So we got the value of k is equals to 1 by 10. Suppose he is asking in the question to find p of x less than 3. Then how to find out p of x less than 3? The meaning is p of x is equal to 0, p of x is equals to 1, p of x is equals to 2. We have to find out. P of x is equal to 0 means 0. P of x is equals to 1 means you will get k. P of x is equals to 2 means we will get 2k. So we are getting total 3k. So the answer becomes 3 by 10. Suppose the question is asking like this: P of 1 less than x less than 4 is asking. So what is the meaning? X value lie between 1 and 4. When x value lie between 1 and 4 means we have to find out P of x is equals to 2 plus P of x is equals to 4. We have to find out. P of x is equals to 2 given as 2k. P of x is equal to 3 here. So P of x is equal to 3k is also given as 2k. So we are getting 4 into k value is equals to 1 by 10. So that is the way of doing the problems based on probability distribution. So just observe here one more question I am discussing. The question is given like this: from a lot of 30 bulbs, total 30 bulbs are there. In these 30 bulbs, 6 bulbs are defective and 6 defective bulbs are there. From this we are drawing 4 bulbs. So total 30 bulbs are there. From these 30, out of these 30 bulbs, 6 bulbs are defective. We are drawing 4 bulbs. He is asking find the probability distribution of number of defective bulbs. We are drawing 4 bulbs, right? We have to find out the probability distribution for number of defective bulbs. Array total 30 bulbs means 24 good bulbs, 6 defective bulbs are there. We are drawing 4 bulbs means one after the other with replacement, right? One after the other with replacement, that is the information given. We are drawing 4 bulbs means you may get all 4 defective, 3 defective, 2 defective, 1 defective, no defective bulb at all. These are the possibilities. That's why X takes the values 4, 3, 2, 1, 0. Next here, first of all tell me what is the probability of getting a defective bulb. Defective bulb probability is equal to 6 by 30, that is equals to 1 by 5. What is the probability of not getting a defective bulb? Not getting a defective bulb means we are getting a good bulb. Not getting a defective bulb means we are getting a good bulb. So good bulb probability is equals to 24 by 30, that is equals to 4 by 5. He is asking find the probability distribution of number of defective bulbs. Number of defective bulbs, maybe 4, maybe 3, maybe 2, maybe 1, maybe 0. Now I am finding P of X is equals to 4. Number of defective bulbs is equals to 4. Number of defective bulbs is equal to 4 means first we have to get defective, next also defective, next also defective, next also defective we have to get, right? So that's why probability of getting a defective bulb is equal to 1 by 5 into 1 by 5 into 1 by 5 into 1 by 5, that is equals to 1 divided by 625, right? Next, P of X is equals to 3. Probability of getting 3 defective bulbs. 3 defective bulbs. Defective, defective, defective. The last case we may get a good bulbs. Defective, 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 good bulbs. So what we can write here? So first we have to get defective. Next also we have to get defective. Next also we have to get defective. But we have to get good bulb. Right? There ends the matter? No. Because why defective in the last chance? Defective may be in the third chance. Defective may be in the second chance. Defective may be in the first chance. They can be arranged in 4 factorial divided by 3 factorial. That is equals to 4 possibilities are there. That's why into 4. That's why we are getting 16 divided by 625. Next. P of X is equals to 2. Probability of getting 2 defective bulbs is equals to 1 by 5. 2 defective bulbs. Defective, defective, good, good. We are getting 2 defective bulbs only. 1 by 5 into 1 by 5. The remaining 2 times we have to get good bulbs. 4 by 5 into 4 by 5. But how many? Into, observe here. They can be arranged in 4 factorial divided by D is there 2 times, that's why 2 factorial. G is there 2 times, that's why 2 factorial. So we are getting the value there as 6. That is equals to, so 96 divided by 625 is the answer. Next case what happens? P of X is equal to 3. Number of defective bulbs is equals to 1. Number of defective bulbs is equals to 1. That's why 1 by 5. Next we will get a 4 by 5. 4 by 5. Again 4 by 5. This is the case. Defective, good, good, good. They can be arranged in 4 factorial divided by 3 factorial. That is equals to 4. So that is nothing but into 4. So you will get 4, 4, 16, 256 divided by 625. Next case, last case is P of X is equals to 0. Number of defective bulbs is equals to 0. That means we have to get all good bulbs only. So there is only one case. That's why first time we have to get good bulb. Next also good bulb. Next also good bulb. Next also we have to get good bulb, that is equals to 256 divided by 625. Therefore, the required probability distribution. So the required probability distribution is given by x is taking the values 0, 1, 2, 3, 4 and their respective probabilities P of x. Their respective probabilities are given by 0 case we got 256 divided by 625. 1 case we got 256 divided by 625. 2 case we got 96 divided by 625. 3 case we got 16 divided by 625. And the last case we got 1 by 625. So these are the respective probabilities. So this is the probability distribution for number of defective bulbs. Right? So no doubt sum of the probabilities definitely you will get 1. So that is the way of doing a particular question. So observe here the same question we can do it like this. Getting defective bulb we are considering as a success. Not getting the defective bulb is a failure. Okay. So he is asking P of x is equal to 4. Number of defective bulbs is equals to 4. Out of 4. So observe here. The same we can write. Out of 4 we have to get 4 defective. Out of 4 we have to get 4 defective. That is equals to we have to get a defective 4 and a good bulbs 0. Out of 4 we have to get 4 defective. 4C 4 into defective 4 not defective 0. And here we can write out of 4 we have to get only 1 defective. 3 defective. Out of 4 we have to get 3 defective. That is equals to 4C 3 into 1 by 5 whole to the power of 3 into 4 by 5 whole to the power of 4 minus 3 1. Right? So next out of 4 we have to get 2 defective. Defective we have to get 2. And 4 by 5 whole to the power of 4 minus 2. Next one is out of 4 we have to get only 1 defective. So that's why defective we have to get only 1. Good bulbs we have to get the remaining, that is 3. Last case is out of 4 no defective. So this is nothing but 1 by 5 whole to the power of 0 into 4 by 5 whole to the power of 4. Whether you observed or not, this total summation what we will get? This total summation is nothing but 1 by 5 plus 4 by 5 whole to the power of 4. This total summation is nothing but 1 by 5 plus 4 by 5 whole to the power of 4. So this is the another distribution we are going to discuss, that is binomial distribution. That means binomial distributions, that we will write it as P of x is equals to R. Probability of getting success R times P of x is equals to R is equals to NCR into success power R into failure power N minus R. So this is the binomial distribution that we are going to discuss in the next class, right? So P of x is equals to R. Probability of getting success R times is equals to, out of n trials we have to get success R times. Success R times, the remaining times we have to get failure. So that is about the binomial distribution and Bernoulli's trials we will discuss in the next class. Okay, bye bye.